The primary goal for this project is to design and build a prototype robot that can autonomously maneuver through a walled maze to find a wooden block in the loading zone and deliver it to one of the 4 delivery points. The controlled movement of the robot are achieved through localization, navigation, and ultrasonic sensing. Tenable is a real-world application that has similar working principles. It's an autonomous tennis ball collector which uses sensors and cameras to detect tennis balls on the court. It can collect and deliver them to a certain location through navigation. The imaginary wall can be defined by the users by selecting zones on the app, and the robot will localize itself to avoid crashing into different areas. The first task is to avoid obstacles. 6 ultrasonic sensors are used to measure the distance from the rover to the nearest walls, 1 on each front and back side, 2 on each lateral side. Besides, a compass integrated with PD compensator was used to identify orientation and perform straight-line bias adjustment. Localization process combines sensor readings with 2D location possibility array. After each movement, the rover communicates with MATLAB through Bluetooth to update its location and get feedback on which direction to go. For navigation method, the paths from initial positions to loading zone are pre-stored as arrays in MATLAB. Similarly, the paths from the loading zone to destinations are also predetermined. For the block pickup mechanism, our team designed an arm with a spade to increase the possibility of grabbing the block. The strategy for block detection is to divide the loading zone into a number of columns. The rover will detect each column in sequence. The main body of the rover was cut from acrylic board, obtained from the MIE444 fabrication facility, while other supporting components such as sensor holders and spade were 3D printed from makerspace printers. As for work allocation, our team consists of 4 members. 2 are responsible for programming. The other 2 are responsible for mechanical and electrical design, fabrication, and report writing. In milestone 1, our rover was able to maneuver autonomously for 20 inches in the maze without hitting any obstacles. In milestone 2, our rover was able to pick up the block that was placed randomly in the loading zone and placed it somewhere outside of the loading zone. The whole process was incorporated with human control through Bluetooth. As for milestone 3, our rover was able to achieve localization from a random starting position with a random orientation. It then navigated itself to arrive at the loading zone and detected the block. After picking up the block, our rover then navigated itself to one of the 4 delivery points and successfully placed the block at the desired destination. The whole process only required 1 assistance to correct a false localization caused by misreadings of front and back sensors. Due to the difference of motor output on each wheel, the biggest challenge for our rover is how to keep the movement on a straight line. Our solution is to implement a compass to get the heading angle, which was then used as a control parameter for PD compensator to keep straight. Ultrasonic sensors were also used to compensate for the cumulative error of the angle control. There was another challenge which was caused by faulty ultrasonic sensor reading. The back sensor returned a value that was much smaller than it should be. Therefore, the rover located itself in a wrong position. This directly led to our instant failure of the first run of milestone 3. We figured out which sensor went wrong and replaced it with a new one to solve the problem. There are 2 ways that could potentially improve the outcome. First, instead of using ultrasonic sensors to compare the difference of 2 distance readings, we will use rotary encoders to accurately measure the distance of the rover moved for each step, because it can convert the angular position of the motor shaft to digital output signals. Secondly, during the test, we found out that the block cannot be detected if it is not parallel to the ultrasonic sensor. Therefore, we will replace it with IR sensor because it can avoid echo effect.